basically states that if you have a sine of angle A and you know the side across from it, it's going to be same as proportional to sine of angle B and side B and sine of angle C to side C in a given triangle ABC. Let's just call that ABC, and that'll be side A, that'll be side B, and that'll be side C. Then this will hold true for all triangles. Okay, this is law of sines. The law of sines helps us solve triangles that are not right triangles. So let's just apply this to problem number 2 in an exercise, and we'll come back and talk about what's known as an ambiguous case. Alright, so let's say you give us an angle alpha, which is 70 degrees, and then they tell us beta is equal to 60 degrees, and then C is equal to 4. So I'm just going to call A, B, and C, so rather than say alpha, beta. Okay, so let's just take a random triangle. It's not a right triangle. We'll call that A, call that side B, call that angle B, and call that angle C. So let's go ahead and put in our angles. So that's 70 degrees, okay, and then this here is 60 degrees, and then they tell us side C, and that is 4. Okay, the only way you can solve for law of sines is if you know a side and an angle across from that. Okay, so we know these two angles, okay, 60 and 70. So we need to find out what that angle is. So all we're going to do is we're going to add 60 and 70, which is going to be 130. Okay, and then we're going to subtract that from 180. So 180 minus 130 is going to give me 50 degrees. Oops, my issue goes 50 degrees. Okay, so this is 50 degrees. As soon as you know this angle, you can use law of sines. Okay, so law of sines says this, I know this angle, I know that side across from it, so I can go sine of C is to C, and I can find any one of those other sides, so let's just go sine of B, so that's easy. Sine of B is to side B, and let's just plug in all the numbers we know. So sine of angle 50 is to side 4 is to sine of angle 60, okay, is to side B. Okay, so what we have to do is now we have to find out what sine of 50 degrees is and divide by 4. So we're going to type in, make sure you calculate in degrees now. Okay, so sine of 50 degrees turns out to be, okay, 0.7660. And we're going to divide that by 4. Okay, and that's equal to sine of 60 degrees. So sine of 60 degrees really rad 3 over 2. So let's just convert that into a decimal. So sine of 60 degrees in decimal form is really a 0.8660, and that is over B. Okay, so on the left hand side I have 0.766 divided by 4. So let's go ahead and do that. 0.766 divide that by 4, and that will turn out to be a 0.1915, and that's equal to 0.8660 over B. Of course, to solve for B, we're just going to cross multiply here. So my B is equal to 0.8660 over 0.1915. So 0.8660 divided by 0.1915, that turns out to be approximately 4.522. So what we just found was this. We found this side to be 4.522. Now, the only thing that's left is to find the side A. So we can go sine of angle 70 is to side A we can use this again because we already have a lot of information about that. that is same thing as this. Okay, sine of 50 is to 4, which is same thing as that, which is same thing as 0.1915. So we'll make our life a little easy. So 0.1915. So our actual answer turns out to be sine of 70 degrees divided by 0.1915. So let's go ahead and find the sine of 70 degrees. Sine 70 degrees, which turns out to be a 0.9, come on, right, 0.939, okay, 7. Okay, and then we're going to divide that by 0.1915. So divide that by 0.1915, and that turns out to be approximately 4.90070. Okay, and that's the side A, and we're going to write that 4.9070. And we know all the angles on all the sides of a non-right triangle. Okay, let's talk about ambiguous case, because there is in law of sines, okay, and side C, let me change that a little bit, because I want to show you about the ambiguous case. So let's call this side angle B. Okay, that's, and then this angle C, so let's call that 60 degrees. Okay, call that 4, and call that 5. Alright, and this is set up for the ambiguous case. Now, since we know this side and this angle A right there, I can just use my law of sine. So sine of angle A is to side A, and then since I know side B, so I have to use sine of angle B is to side B, which is 5. So let's plug in everything we have. Okay, so that would be sine of 60 degrees is to A, which is 4, and that is equal to sine of angle B is to 5. So now I'm solving for angle B. So first thing I'm going to do is I'm going to take sine of 60 degrees, okay, and then I'm going to divide that by 4, okay, and then take that answer, which is a 0.2165, and I got to multiply that by 5, and that'll give me sine of B. Okay, so when I multiply that by 5, I'm going to get 1.08 2. Really? Wow. Alright. So we're going to get sine of B, and right now I can stop right there. I can't go any further because that will never happen, because sine of B, sine of anything has to be less than 1. So this is none. I get no triangle. No triangle. Okay. So that problem is done. So how do we get 2 triangles? Well, let's do one where we do get 2 triangles. So let's try, cross our fingers. Okay, let's try number 11. Okay, so where it gives 4 for B, inside C is 6, and angle B is 20 degrees. Okay, and hopefully I get 2 triangles on this one, because I'm trying to show that you could have 1, none, or 2 triangles, okay, whenever you have the law of sines. So let's draw a random triangle. Okay, I want to draw a random triangle, and I want to put the angle B right there, okay, which is 20 degrees, and that means this side across from that is going to be 4. Okay, I'm going to call this side C, okay, and that's the angle C, and we'll call this angle A, so that'll be side A. Alright, so since I know, I do know what C is, so let's go ahead and put that in there. So C is 6, so let's put that in there. Okay, now I can use sine of 20 degrees is to 4 is sine of C, because I know that side. Sine of angle C is to 6. So let's go ahead and find sine of 20 degrees, and then we're going to divide that by 4. So divide that by 4, and that turns out to be 0.0855. And we're going to multiply that by 6, and that's what my sine of C is. So multiply that by 6, and that turns out to be 0.5130. And that's my sine of C. So how do I find C? C is obviously sine inverse of 0.5130. So we're going to take sine inverse of 0.513, and then that turns out to be, okay, sine inverse of it. Sine inverse of 0.513, and that turns out to be approximately 31 degrees. So we're going to round off to the nearest degree so we can make it easy on ourselves. Okay, so this is 31 degrees. Well, obviously if that's 31 degrees, we know what that is. Okay, and that's 20 plus 31, which is 51, and subtract 180 degrees from that, and that turns out to be 129 degrees. Okay, once we know that's 129 degrees, we can find side A. Okay, then we can go sine of 129 degrees is to side A is to sine of 20 degrees is to side 4. Since we already know that to be 0.0855, I can write that as sine of 129 degrees, sine of 129 degrees, which is 0.7771 over 4 is equal to 0.0855. Okay, is over 8, not 4, over 8. Alright, so to find A, my A is equal to 0.7771 over 0.0855. So we're going to divide that by 0.8. Okay, 0.8. 0.08. Go back. 0.0855. Okay, and that turns out to be A is equal to approximately 9.089. Okay, so this side is equal to approximately 9.089. Alright, now do we have another triangle or not? So let's suppose that we know this side, okay, and we know this side. And is it possible to make an isosceles triangle keeping this side like this? So if I were to draw another side like that to match up with this side, okay, then I'm going to have a different triangle right here. This angle B is still the same, which is 20 degrees. Okay, this side here, C, is going to stay the same, which is 6. And my side B is going to stay the same, which is 4. And I can still have a small triangle. Now, how do I know that works or not, if I have one or not, is this. That since these two sides are going to be, this side here is going to be the same as this side, okay, and we know this is 31 degrees, that means this is 31 degrees also. So 31 minus 180, so that means this angle here, the inside angle right there, has to be 31 minus 180, that'll be 149 degrees. Okay, 149 plus 20, which is the angle B, which is this is the 20 degrees. Okay, that adds up to 169. And yes, there's going to be another one. Okay, so 169 is 180 minus 169 is going to give me 11 degrees. So that my angle A could be 11 degrees. Okay, so I have to go back and find that. And what if my angle A turns out to be 11 degrees? So let me do that real quick here. Okay, let me create a little bit of space. Okay, let me erase this. And okay, so we're talking about a different triangle now, where it looks like this. Okay, I redraw that. That's going to be angle B, and that's my 20 degrees. And this is my angle C, and that is my 149 degrees. And this is my angle A, which happens to be 11 degrees. Okay, and then this side never changed. That's 6, and this side never changed. That's 4. So the only thing that's left is to find the other side, other number for A, because I could have two possible triangles, and that's why it's called ambiguous case. So we're going to do the same thing. Okay, since we already have sine of 20 is equal to 4, so sine of 20 degrees over 4, which is really 0.0855, is going to equal to sine of 11 degrees is to A. Okay, so we need to find out what sine 11 degrees is. So sine of 11 degrees, okay, turns out to be 0.19. So this is 0.0855 is equal to 0.1908 over A. So when we cross multiply this, my A turns out to be 0.1908 divided by 0.0855. So let's do that. 0.0855, and that turns out to be 2.2. So A is 2.232. So I could have another side with a 2.232, and side 4, 6, 20 degrees, 149 degrees, and 110 degrees. Okay, and that's one triangle. Or I can have my original triangle where I have a 31 degrees, 129 degrees, and 20 degrees. So those are all the possible triangles. That means I could have two triangles. That's law of sines with an ambiguous case. Okay, alright, let's go ahead and stop there, and we'll take care of law of cosines.